Welcome to another video lesson. This is our last unit or last video lesson for our probability unit, and today's lesson is on dependent probability, and it is video lesson number 26. For today's lesson, of course, you're going to need the video notes you were given in class. You will need a pencil or pen to take notes, a highlighter, marker, or colored pencil to highlight some key information in the problems, and you will need a calculator. Let's dive right in. For compound probability, dependent events, again, this is just a formula that we use to determine the likelihood of two separate events occurring at the same time. This is the same as what we talked about yesterday, in our last video lesson. So with dependent events, these are different from independent events in that the result of the first event changes the results of the events that occur after it. So with dependent and independent events, it can be, more than any time you have more than two. So it could be 3 events, 4 events. For our SOL and for our lesson, it's only going to be 2 events. So if you look at the example down here below, it says Susie selects 2 chips from a bag of red and blue chips. She selects 1 chip and does not replace it. So without replacement are the key words with dependent probability, because what it's saying is that you're not putting back what you took out. And so when you don't put it back, then the number that are in the bag or the number that are in the bucket, whatever, are less because you took one out. So again, it's selecting 1 chip and not replacing it before you do your next selection. And here's another example. So again, dependent probability is when an item is not replaced. It changes the total possible outcomes, and that makes it dependent because the outcome of the second event depends on what was done first. So here's another example. What's the probability of selecting an Oreo cookie, eating it, and then selecting a peanut butter cookie? So if we look at this example, we have pictures down below. We have 3 chocolate chip cookies, we have 6 peanut butter cookies, and we have an Oreo cookie. So it comes to 10 cookies altogether. If I take that Oreo cookie, because it's saying what's the probability of selecting an Oreo, that is 1 out of the 10 cookies. Well, if I eat it, that Oreo cookie is now gone. So when I look at my second one, what is the probability of selecting a peanut butter cookie? There are still 6 peanut butter cookies, but there's no longer 10 cookies because I ate the Oreo. So now there's only 9 cookies. I ate that Oreo. So it's now 1/10 times the 6 peanut butter cookies, but now instead of 10 cookies, there's only 9 left. So before I'll multiply these, though, I am going to simplify the 6 and the 9 because they can both be divided by 3, and that would simplify to 2/3. And so then when I multiply, I get 2 over 30, which again I can simplify by 2, and my final answer would be 1/15. That is just an example for you to see. You can pause the video and write it down, but you don't have to. So when you're calculating compound probability with dependent events, it's important, A, that you recognize that it's dependent, meaning that the outcome of the first event will change the outcome of the second event. But it's the same process as independent. So you find the likelihood for each event, and notice that with dependent events, this is important, the denominator decreases by 1 for each event. So that means the denominator, the bottom number, is going down. So we're in the cookie example in the previous slide, we saw that there were 10 cookies, I ate 1, and then we were down to 9. So it goes down by 1. Now, once you've done that, and you have those 2 fractions, you multiply those fractions together, and don't forget to simplify. That's where you're going to get caught. Now, there is a caution I'm going to caution you on. Sometimes the numerator decreases by 1 too, and you have to stop and think, picture in your head what's going on in the problem. These are thinking questions, and that's what's going to mess you up if you're not careful. So look at this first example. We have a drawer containing white socks and 4 gray socks. Why we use socks all the time, I don't know. But if I have 8 white socks and 4 gray socks, I have 12 total socks. So I ask myself, what is the probability of picking a white sock, not replacing it, and then picking a gray sock? Well, white socks is going to be 8 over 12. I'm not replacing it, so that white sock is now gone. So when I go to pick my gray sock, instead of having 12 socks now, because I took one of those white socks out and put it on my foot, it's no longer in the drawer. Now I have still the 4 gray socks, but instead of having 12 socks in my drawer, I only have 11. So it's going to be 4 out of 11. And then of course you're going to multiply. But I'm going to go ahead and multiply this one across. I would get 32 over 132, and you're going to notice with these, the numbers get really big really fast. Then again, I want to simplify, so I'm going to divide both of these by 4, and I end up with 8 over 33 as my final answer. So again, these are dependent events because the outcome, the first fraction, because I'm not putting something back, changes the results of the second fraction. And let's look at the second example. Again, we're back with the socks. So we still have 12 total socks. What is the probability of picking 2 gray socks this time without replacing them? So I take one sock out. My first fraction is not any different. It stays the same. I have 4 gray socks, 12 socks in my drawer. But I take one of those gray ones out, I put it on my foot, so now I only have 3 gray socks because one is on my foot, and there's only 11 socks in the drawer. So in this case, this is that caution I told you about, where not only does the denominator go down by 1, but the numerator goes down by 1 as well because I'm selecting the same type of thing that I selected in the first one. So since I selected both gray socks, the second one, there's fewer to choose from. Instead of being 4, one's on my foot, so there's only 3 in my drawer. Again, you're going to multiply. When I multiply this time, I get 12 over 132, divide them both by 4, and I end up with 3 over 33, but I can still divide these by 3, and I end up with 1 over 11. For the last 2 examples, we're going to use a deck of cards. And I put a picture here because I know a lot of you are not familiar with what is in a deck of cards. So in this case, they're saying, what is the probability of picking a king, playing it in a game, and then drawing a second king? So in this case, picking a king, I highlighted them purple, there are 4 kings in a deck of cards. So my first fraction is 4 out of the 52 total cards that I have there pictured. If I play that king in a game, that means it's no longer in the deck. So in my second one, since I'm playing it, it's no longer there, I'm going to take one of them away. So now, if I'm trying to draw a second king, there's no longer 4 kings. There's only 3. So I'm going to, 3 would be my numerator, and instead of being 52 cards, there's only going to be 51 because I played that king. So then I multiply those together, and I'm going to simplify 4 over 52 because I can divide both of those by 4, and that becomes 1 over 13. And I can actually simplify the 3 and the 51 by dividing them both by 3 and get 1 over 7. So then my numbers are much smaller to multiply, and I don't have to simplify when they're really big and it's more confusing. So then 1 times 1 is 1, 13 times 7 is 91, and I am done. I don't have to do any more simplifying. Woot woot! And our last example is number 4. What is the probability of drawing a jack? And there's 4 jacks, just like there's 4 kings. Not replacing that jack. Oh, sorry, that's 4 out of 52. Getting ahead of myself. So there's 4 jacks out of 52 cards. That's my first fraction. We're not going to replace that jack, and then we're going to draw an ace. So there are 4 aces, and I took that jack out, but there still are 4 aces because I didn't take any of those away. I just took a jack out. So there are 4, that's my numerator, but now instead of 52 cards, there's only 51. So I will then multiply those, and I can, of course, simplify 4 over 52. I can divide them both by 4, and I'll get 1 over 13. Then I multiply that times the 4 over 51, which I cannot simplify, and I end up getting 4 over 663, which I can't simplify anymore, and I am done. So that sounds like a really crazy fraction, but that shows you how low that probability would be. If I were to divide those and get a percent, it's going to be really, really, really small, meaning it has a very small chance of actually happening. So that's, remember, what our ultimate goal is to determine, is it impossible, unlikely, certain, more likely, less likely, equally likely, all those things. So don't just get hung up on the math part of it, but think about what that really means. And that's it for this example. And before I tell you to show what you know, I want you to go ahead and draw a star in the bottom right corner of your paper. Draw a star in the bottom right corner of your paper. And then you can go ahead and show what you know on the homework quiz.